our tangent values were found between the first and the fourth, excluding the vertical. Okay? What we're going to do today is still follow those same rules, but place them into a different quadrant using the reference angle. What's nice about this is that you have to use your calculator. Okay? You've got to have your calculator for this one. Notice that they're going to give you these things in degrees. So what mode should you be in? Degrees. Dun, dun, dun.
Good job. That's the worst noise. 89 divided by 9.
Hello? 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 Hello?
Hey, have a good case for this.
Hello? What doesn't work?
98.
All right.
Okay, wait, I have a question. That little thingy, is it beta, like a TH, or is it theta with a TH?
TH.
98.
I swear it's
Theta.
7 cents.
Theta.
Figures.
He's Italian. What do you expect?
And
No offense to the Italians. What's that? What?
There's definitely one
What?
here.
He says figures.
What?
And then he says,
You seem to forget that I went to college with him.
You did?
You see, we didn't forget, we just didn't know.
Oh, you didn't know that?
I know.
Oh no, Seb and I went. We had, Seb and I were in classes all the time together.
Where'd you go?
Northern.
Here?
No, the other Northern. Yes. So I would sit there next to Seb in class.
And you would do here?
I wasn't sure. And you turn on and you just slug me. So, but no, yeah, we went to class a lot.
That's so funny.
So here's what happened. Yeah, I was that kid you didn't want to sit next to in college. If you have to find theta, remember this is a one-step problem. Theta is going to be the inverse sine of negative 1/4. Remember, this is just using your calculator. Negative 1/4 doesn't bounce into any quadrant, into any triangle that we're using or anything like that. When you see these styles, you have to have a calculator to do this. Remember that sine gives you solutions between the first and the fourth quadrant, between pi over 2 to negative pi over 2. In other words, 90 to negative 90 degrees. Okay? When you type that in, what do you get for your theta?
14.47.
Is it positive or negative?
Positive.
Negative.
What did I do? It's negative.
Graph the negative sign.
Oh, I didn't know it was negative.
There you go.
Negative, everyone.
It's negative, okay. So your angle comes out at negative 14.97?
14.48.
Excuse me, okay. So your angle, remember when you find these sine values, the sine values go between positive 90 degrees down to negative 90 degrees. That means it's dropped down 14, or negative 14.48. So the reference angle off that is 1448. That's how far it is off of the x-axis. Okay? It's asking you to place this angle into which quadrant? The third. It's asking you to place this into the third quadrant because aren't your sine values in the third quadrant, aren't they also negative?
Yes.
So if the reference angle is 1448, how far, what is this overall angle then? What do?
You add 90 to it?
No, you add 180. Remember, you're coming off the x-axis, so if I'm coming down off the x-axis 1448, all I'm doing is just going to add in 1448. So 180 and 1448 is 194.48. That's it.
Wait, are you always just what's the measure?
Depending upon what quadrant you're going to, you're just using the rules of reference angles.
But what does the,
What is?
What this, can I just stop talking and let me finish? The original question asked, what angle has a sine value that is equal to negative 1/4 that is in the third quadrant. Your calculator finds it in the fourth quadrant or the first quadrant. You need to utilize reference angles to bounce it to where it belongs. Since between the fourth and the third quadrant, the y values do not change, that's why all we have to do is just move the reference angle. That means it comes, if it went down 14 and change in fourth, it's got to go down 14 and change in the third. To go down, you're adding to the 180 degrees to make the degrees more. Check your answer by typing this into your calculator with the sign. It should come pretty darn close to negative 0.25. All we're using is reference angles. Okay? What do you get?
Negative 0.25.
Pretty darn close then. So would you say that we did that correctly?
Just sign or.
Well, 194.48. That's it. Okay. That's what this is all this is, guys. It's pure calculator work of putting in values. Okay. I'm not worried about sig figs. I like 2 decimal places. In this case here, sine of theta is negative 0.35. And I want to go to the third quadrant again. Notice the reason why it's going to the third quadrant is because the original value is negative, which means the only other place it's going to be negative for a sine value is the third quadrant, because it automatically puts you to the fourth,
Oh, okay.
and the only other place it'll be is there.
Oh, I got that.
So your sine values, remember what the calculator is doing, it's going to find some value between these two quadrants, between positive 90 to negative 90 to give it to you. Obviously, this is going to drop to the fourth quadrant because it's negative. What do you get for the angle?
Negative 20.49.
20.49. So your reference angle becomes 20.49. When you bounce that into your third quadrant, you're adding 20.49 to 180, and you get 200.49. That's it. You're just mirroring values into other quadrants with decimals, as opposed to when we did that with our 30, 60, 90s before. Okay. Tangent. Tangent theta is 2.4. Tangent theta 2.4. Notice tangent's positive. What quadrant will the calculator give you a positive tangent? First. Well, if it's going to be positive, where else is tangent positive?
Oh, tangent.
Yeah, it's got to be. It's going to. You're going to originally the calculator. Remember, is going to find it between the first and the fourth again, between 90 and negative 90, not including pi over 2, negative pi over 2, and that's where you get your asymptote. When you type it in your calculator, it's going to give you a first quadrant problem. The other quadrant that gives you a tangent value that's positive is the third. So to get this angle into the third quadrant, the reference angle again is going to be 67.38. What do you do to it?
Add to 180.
Add to 180.
247.3.
What happens if,
We're in a different quadrant?
well, no, like, something happens where, you know, it asks for a sign of something, and then it says to put it in a certain quadrant, but it can't work out.
You won't have that.
Okay, good.
You won't have that. It's because your sign values are only positive or they're only negative within 2 quadrants.
Okay.
And this is the only way these work.
Okay.
Eventually, when we solve equations, and I'll show you an example of what's called a general solution, I'll show you an example of that towards the end because that's where we're getting towards. And it's a little bit different in how it appears. It's not going to be that. All right? Ready? Yeah, because it's coming off the way.
This one's a
Yeah, question.
So, why in the tangent, why did you put it in first quadrant?
Because
Like before you bounced?
before I bounce, because the calculator told me that the inverse, when I find theta to get that value, it's 67 and change.
Yeah.
That angle has the tangent of 2.4. So what I did is I put it into the quadrant that it belongs. That way I can figure out what reference angle it
Why
is.
did you go?
It's
Oh,
positive.
just like 1 through 90?
Yeah.
But then
Because-
why did you put 20.49?
Because it was negative. Because it goes from negative 90, or excuse me, positive 90 to negative 90.
Alright, I'm just confused because like it's just, do you want us to put a negative sign if the reference angle is on one or?
Oh, you can, that's fine. I was just using it knowing that this is my reference angle, because it doesn't matter what the original is, because I'm gonna have to bounce this someplace else. It was just me being shorthand, that's all. Whatever you think is gonna be easier for you to recognize, as long as you know that you move down to the fourth quadrant, you know when you go to the third quadrant, you're just adding to it, that's all.
Yeah.
Because your reference angle is always an absolute value. It's always gonna be a positive value.
Yeah.
That's all.
Are we just working with between 180 and 270?
No, I know, that's what I'm getting at. It just so happened to be double up. Those were the first couple of examples that I had. What's up? Oh, usually they had a question. Just joking, help her out. Jeez, hold your breath, people.
It doesn't forever.
Three, what'd you get for your reference angle?
79.3.
All right, so you're 79 point what?
Oh.
So you're up 79 and change, and it wants you to be a positive tangent value. The only other quadrant that has a positive tangent value is in the third quadrant, because tangent is y over x, so it's negative over negative, which is positive. So into the third quadrant, to have that same reference angle, you're adding it to 180.
Yeah, because it takes 180 to go.
Correct. So this theta value within this quadrant is what?
180. Oh.
59.32.
Okay. Sine value is negative 0.89. Remember, sine value goes between first and fourth, so it probably gave you a negative angle in the fourth quadrant. They gave you a reference angle of what, 67 something?
Yeah. Or 62.
62 point, negative 62.87.
So it's bounced to the fourth quadrant, it's a negative angle. The other quadrant that sine is negative is third quadrant. It still has to have the exact same reference angle so that it stays on the same horizontal line. So here you have to, oh, I'm sorry, I was reading the wrong one, I'm sorry. I was reading it as fourth. Now to get in between here, because the sine value goes between 90 to negative 90. To have this reference angle in the fourth quadrant, you spin around. You don't add, because then you're working off the y-axis. Do we work off the y-axis? No.
You do 360 minus.
You do 360 minus that. You're always bouncing off.
Answer?
No.
297.13.
Oh, no.
What was it?
297.13.
Oh, because if you added 270, you would be getting the...
You're referencing off the y. Never reference off the y. Okay? When I go to cosine value of negative 0.6.
Oh, 126.87.
I was confused by that.
So you're saying this is the angle at 120, what is it?
126.87.
126?
Yeah.
4.87.
Sorry, it sounded like someone else said something else. Do I have to move that angle?
No.
Nope.
Whoa, it's already in that quadrant.
I was confused though. How can you get a reference angle of 126 when the quadrants are divided up into 90 degrees?
That's not
I feel like I'm having a lot of...
This is the value of theta between 90 and 180. That is the cosine. It gives you that. It's not, it's asking you to find it in Q2. Second quadrant, remember cosine goes between here and here. So you didn't have to move anything in this problem. Yeah.
All right, I'll do it.
Yes, ma'am.
Can you scroll up to 13? Like, how come, like, that one's already in the 270 to 360, and we had to find a different one for that?
What's the angle it gave us when we hit the button?
62.
Gave you a negative 62.
Oh, it has to be between that number value, not the quadrant, okay.
Correct. We're using that negative value as a reference angle to move it back to that same quadrant within those parameters.
Oh, okay, I get you.
All right.
That makes so much more sense.
Tangent of 1.53. What's the angle we're giving it?
56.83.
Is that in the first quadrant?
Yeah.
Do you have to move it?
No.
Nope.
Oh my God, I just did that.
That's all that is.
There it is.
That value is right there. Now, what this is going to allow us to be able to do as we continue is the next little bit.
When it turns into like an equation.
When it gets into like an equation. Now, this is where calculators go away completely again, because these answers are all going to be based off of our triangle. Okay? So, if you think of this as a two-step equation, if I just covered up this nasty word of cosine and had 2x minus 1 equals 0, what would you do?
Add one.
Okay, so that means some angle has a cosine of 1/2. What triangle has a cosine of 1/2?
3069.
3069.
Is this cosine of x and then subtract 1, or is it cosine of x? It's just.
Cosine of x minus 1. So you're telling me it's a 30, 60, 90, so you have root 3, 1, and 2, so it's a 60, so it's a 60-degree angle. But I'm talking about radians. These all go to radians now.
So pi over 3.
Pi over 3, very good. So that means your x value is at pi over 3. Now here's where it gets a little bit interesting. Cosine has a positive value of 1/2 within what two quadrants?
Wait, no, 1 and...
Cosine is positive here. And cosine is positive here. Cosine is positive in the first and the fourth quadrant because x is positive. This gives you your reference angle, the first quadrant of pi over 3. Right there. What's the other angle in the fourth quadrant that has the same reference angle? 5 pi over 3. Because 2 pi is the same thing as saying 6 over 3. So you subtract the pi over 3. So these are the two angles that have a cosine value equal to 1/2. Or are they? Let me ask you this. How long does it take me to get from pi over 3 back to pi over 3? An hour or two. Yeah,
2
thanks.
pi.
2 pi. So every time I go 2 pi to pi over 3, do I wind up there?
Yeah.
No matter how many times I go around, I still wind up there. So you're going to have two different types of solutions. You'll have what's called an absolute solution, which is within one revolution. You're going to list them all out. Or you're going to have what's called a general solution. A general solution means that how often does it take you to get back to the same spot?
So you can have like as many as you want.
Right. Because every 2 pi n, like number of times around, you're always going to wind back into pi over 3. Okay?
Yeah.
These come into play. It's not always going to be plus 2 pi. Sometimes it can be plus pi over 4. Sometimes it can be plus pi. It depends upon what value.
2 pi over 3 would be another.
Right. The other one you'd have to, if you take this and you add in plus 2 pi n,
Yeah.
because you're gonna, every time you get around, you're going to be back at 5 pi over 3.
What's the end?
Number of times you go around. Number of revolutions.
Why
Like,
is it not always 2 pi?
because sometimes, for example, let's say a tangent. Tangent, remember, is positive first in the third quadrant. To go from here to here, it's just pi. And to go from here to here, it's just pi. The other ones that happens is sometimes you wind up with your pi over 4s. Oops, I don't know those two. To go from pi over 4 to 3 pi over 4 is how much? Half pi's. To go from here to here is half pi, here to here, half pi, here to half pi. So depending upon the values of what you're being placed at, your general solution can change. We spend a ton of time with the solving stuff. The solving part's easy. It's the idea of how long it's taking to get to the next part if it asks me to do that. Okay. And the other little bit, we kind of, yeah.
So why would this one that we just did only have 2, but ones like that example have 4?
Because it placed a parameter on it.
Okay.
Whereas the other ones will say, what is the general solution, or it'll say, what are all solutions within one revolution. That's why. Okay. Yes, sir.
Wait, which one's the general and which one's the?
General with the, you tack on the end value. The absolute, yeah. The absolute,
Absolute is the first one you find.
it's however many you find within one revolution. Sometimes there's 1, sometimes there's 2, sometimes there's 4.
So like it would have been pi over 3 and pi over 3.
That would be your absolute, yeah.
And then general.
Now, the other little bit we're going to talk some more of probably tomorrow as well is this.
That was hard.
It's not. It's
Oh,
impossible.
You just find the value and then.
We did this yesterday.
I know, but then do this one.
I don't remember how.
Work inside out.
Okay, so cosine or the inverse cosine of root 2 over 2 is 45, right?
Okay.
Sine of 45.
Is what?
I don't know.
What triangle is it?
45.
Draw it out.
Opposite of 1 over 2.
Right. So this.
So it equals root 2 over 2.
What?
Do a problem. Everyone's saying the problem.
It equals root 2 over 2.
They give you one that's a little bit more complex. And I promise to stand out in your way.
No, it's not even like I see the problem.
Nobody else talk for like 2 minutes.
Thank you.
I need to leave this class.
Mm-hmm.
I don't remember what secant is. Secant goes into cosine, right?
Good. We have a little bit of time to get out there. It works out well. We just were having the inverses this year, but we didn't have time to do that last year. We get them a little bit more prepared for the pre-calcs next year. Good fun. It's good fun. Nothing better than some composites. Oh, no, yeah.
I know you.
Oh, I have. I actually looked it up in a book, because I was killing time. If I'm at the inverse sine of root 2 over 2, what triangle does that get me into? 45. Good. So we know that the inverse sine root 2 over 2, but it's negative. That means I'm in the 4th quadrant. Okay. So I'm at a 45, so I have a 45-degree angle, 1, 1, and root 2. But this opposite is the negative, since that's the y values. Okay. The hypotenuse will not be negative. Now, if I want to do the secant value of this, the secant would be hypotenuse over adjacent, which is?
Jason will be I did, yeah, no negatives.
It's supposed to be negative or no?
No, because your negative value is your y value. the vertical, because your reference angle always is placed at the origin. So if it's my negative 45, so it's dropped down there, so it's 1, negative 1 in root 2. I think it's just root 2. Yes, ma'am?
I only managed to get this by dumb logic because the sine and cosecant and secant are the same, but
It's fine. There's nothing wrong with that.
So all the negative tells us, like, when it's negative root 2 over 2, that just tells us that it's in the fourth quadrant because it's down like that.
Yeah. Good
You
drinking.
wait until the last 4 minutes of class.
Here's what I want you to do. Same section, so it's, was it 13.4? Let's do 44 through 57. So 13.4, page 7,
95.
thank you. Work on those, and we'll build out.
You like the new this last week? Same page.
Yeah. Yeah, please just use the same page. I mean, use the same paper.
trees.
Probably.
No,